that will attach to the DNA in the sperm cell. So in order to make a cell count, total cell count, we will use a reagent. We make a dilution of the semen using this reagent. This reagent will kill all sperm cells, break up the cell membrane and remove the tail, so you have the nuclei freely available. And then we have a cassette like this. Here we have propylamide, so it's already in there. We take the diluted semen, this was the diluted semen sample, then we put in the cassette, push down the white piston here, then the sample will be soaked up to here approximately and dissolve the propylamide. Propylamide will then attach to the DNA, and we put this one into the machine. The machine will push down this piston to here, forcing the sample through the mixing chambers and into the measurement window. This is where we are counting. We shine green light through the chamber. So it fits in there. We shine green light through, and the propylamide that is attached to the DNA will give off red light. That red light is focused via lenses, it's a microscope basically, and optical filters on a camera chip. So we take a picture of the light coming from the semen, from the sperm sample, light spots you have in the picture, and the instrument knows the volume of the window, so it calculates back to cells per milliliter of original sample. That was very shortly what it does. One day you want to measure a sample from a dog, you can change it. The instrument is operated by function codes F11. Since you are always testing stallions, you will always be using the same dilution factors. I mentioned before that we are making a dilution of the semen. We're doing that for two reasons. One reason is to bring the concentration of the sperm cells into the optimal range for the instrument. In the picture, we will be counting between 1,500 and 7,000 cells.
Per million?
No, in total.
Total.
Yes. That is the optimum range for the instrument. So it's quite a lot of cells. That is why the accuracy is very, very good. The statistical significance of the counting is very good because we are counting so many. If we are counting less than 1,500, the statistical error goes up because we have fewer cells. If we are counting more than 7,000, it becomes difficult for the instrument to count because the cells will be lying on top of each other. So the optimum range is between 1,500 and 7,000. And we don't expect you to calculate that. Instead, we have made this chart where you have the expected concentration of the semen here, and then you for a stallion, let's say it will be 250 million.
But that's the concentration we want finally?
No, that is the concentration that you expect to find in the semen. For example, in the ejaculate. Maybe it will be like 250 million in that range. Then you go in here until you find the black range. The black range, this is where you have the optimum accuracy. So for stallions, I recommend always using a dilution factor of 101.
101.
Yeah. So 1 part of semen and 100 parts of reagent. If you do that, you will have optimum accuracy from 125 million to 500 million. Most of your animals will be in that range.
Yeah, most of.
Yeah.
Sometimes we got semen concentration less than 100.
Yes.
Yeah, but most of the time.
It's not a big problem because you can still measure in the gray area. So you can measure all the way down to 50 million. The accuracy is slightly...
Black is optimal and
Yes.
gray is it can measure.
Yes,
Yeah.
yes. So if you find yourself in the gray area with, let's say, 100 million or 90 million, it's okay.
Yeah.
Unless you want it to be very accurate, then I would suggest to select another dilution factor and repeat the measurement. But in most cases, even if you are in the gray area, it's okay.
Yes.
And by the way, if you're measuring the ejaculate, you need to treat the semen sample afterwards. You need to extend it, etc. So my recommendation is for stallions, always 101.
Yeah.
So we will tell the instrument that we have diluted the sample 101 times. Change dilution factor, we call that the DF.
Yes.
F0. Dilution factor is now 201.
Yes.
Enter the new dilution factor. We agreed that would be 101.
Yeah, 101.
So you just type in 101. Okay. DF1. That is the dilution factor for the first measurement. Remember, we have enabled the viability mode. To measure the viability, we make 2 measurements. One, total cell count, where we are using the reagent. And then we are repeating the measurement, but instead of diluting with the reagent, we are diluting with PBS. PBS is a phosphate buffer saline solution that will not harm the cells at all. This one will kill cells, but PBS will, well, basically it's a simple extender.
We need separate solution for
Yes.
totally measured.
Yeah, this one is for total cell count.
Yeah.
You kill all the cells, and the thing is, the instrument can only see cells which are dead.
Yeah.
If the membrane is intact, the propionum iodide will not enter, and we don't see it. And that is why, to make the total cell count, we kill the cells with this reagent.
Yes.
That gives us the total number of cells, but we don't know if they are good or bad. Therefore, we make one more measurement, and instead of killing the cells, we are using PBS. Then we can only see the cells with a damaged membrane, because the propionum iodide can get in there. The intact cells, the good fertile cells, we can't see them. So we have the total cell count and the non-viable cell count, the damaged cells. The difference between the dead ones or damaged ones and the total, that's the good ones.
Yeah.
So therefore we can have 2 different dilution factors. Usually I'm using the same dilution factor. DF1 is for total cell count because we always make that measurement first. Secondly, we measure with PBS, and the dilution factor when using PBS, we call that DF2. And you can see here, to toggle between DF1 and DF2, press escape. This is escape, and you see DF2 is 201. We haven't changed that. DF1 is 101.
Yes.
I will make DF2 similar to DF1 by F0. You already know.
Yeah.
101. Good. That's it. Now I will turn off the instrument
Save.
and save the parameters. And from now on, these are the default settings. So even if you change something during the day or somebody else changes something, when you turn on the instrument, it will always be on the default settings. So much about the instrument. Now, the question is now, we have told the instrument that we will dilute the sample a factor 101. How do we produce that dilution factor? That you can see over here. We look up how to obtain a dilution factor of 101. For example, 50 microliter of semen and 5 milliliter of reagent. That gives you 5.05 milliliter,
Yeah.
and that's a factor 101.
Ah, yeah.
You see?
Yeah, yes. I got it.
So 50 microliter. Funny, the pipette is already at 50 microliter. And 5 milliliter of reagent. Incredible, it's already at 5 milliliter.
Yeah.
So we are ready.
Okay.
Two milliliter, is that? No, don't work. Now the semen is dead.
Do I need to put the sample first in the cup? How about first I put reagent in the cup first?
Yeah, I'll get back
It
to
doesn't
that
matter. Okay.
because we need to measure it.
Oh, yeah.
Then I'll explain to you. Just put this one in, push down the piston, and now the sample is inside to there.
Oh, yeah.
Can you see it?
Yeah, yeah.
Yeah?
Yes.
Then you put the cassette in here until it clicks, then press run, and then the instrument asks, is this a total cell count or a non-viable count? We used the reagent that killed everything, so it's a total. Now you see it is pushing down the piston.
Oh, yeah.
So now the sample is traveling through the mixing channels and into the window. Then you'll see green light from light
yeah.
diodes. There it is. And once more. Now we have the picture taken by a camera chip, and the instrument is counting now. And that's our result. 21.4 million cells per milliliter.
Yeah.
And here you have the picture. This is the picture of the sample that we have just made. You have the documentation, dilution factor 21 in a stallion, and the result is 21.39 million cells in total. T indicates it's a total cell count.
This screen is this.
A part of it,
Yeah.
only a part, but yes, that is the picture that we took of the cells inside there. And the instrument has divided the area and counted how many white stars do we have in the picture. Every single white spot, that is the nuclei or nucleus from a sperm cell stained with DNA. But it also means if you have gel particles in the semen or debris or other contaminants, you will not see it. You will see it on the CASA system, but not on the nucleocunter because they don't have DNA.
Yes.
It is only cells with DNA that will appear. And this is why this is even more accurate than the CASA system. Okay, that was the total cell count.
그러니까 책에도 이거밖에 없죠.
아 그래요?
그러니까 지금 간단하게 우리가 온도 측정하는 거는 포토미터 이걸 쓰거든요.
예.
근데 이게 이제 이 스탠더가 들어가면 이게 어차피 스펙트럼으로 하는 건데
예.
온도 측정이 안 되잖아요.
예.
근데 이거 다음에 할 수 있는 거는 책에도
This is our sequencer. And now we want to measure the viability. So it's the same as before. Microliter. And then 2 milliliter, not of the reagent this time, but of PBS.
We don't have to be confused. It's very important.
Yes, that's right. But you will find out immediately. So, in this solution, the sperm cells are still alive because the PBS will not harm them.
Yes.
And we will only be able to see in the picture the ones with a hole in the cell membrane. So it's basically the dead ones or the damaged ones. Just do it the same way. It's the same cassette. Put it in, push down the piston, and in we go. Press run, and now we have to press 2. This measurement takes a bit longer. The first one takes 30 seconds of the total cell count. The non-viable count takes about 80 seconds. The reason is that when we use the reagent, we are completely disrupting the cell membrane, so they are gone. When we are using PBS, we have all kinds of stages of cell death. We have cells which are alive, well, and we have cells which are completely dead. And then we also have some cells where maybe they are beginning to die. They have a small hole in the membrane, and we need to count them because they are not fertile. But it will take a while for propylamide to get in through that very small hole. Therefore, we are allowing more time for propylamide to get in and stain the DNA so we can see the cell. Basically, we are making 3 measurements with a time interval and then extrapolating. The whole procedure takes about 80 seconds. Now back to your question, if we could put reagent in first. Oh, sorry. 7.2 million non-viable cells. If we click here, the software will calculate the viability. 66%
생존율 60.
viability.
죽은 걸 읽어내.
That's okay for us, Daddy. Has it been frozen, this semen?
No.
No.
Yeah.
It's fresh, extended semen.
Yeah, yes.
Yeah.
Just
So
cold semen.
From today?
Cold. No. We made that semen maybe 3 days ago.
Ah. And you still have a viability of 66%. That's good. If it was frozen, it would be fantastic. For frozen semen, I would expect like 50% viability. But this is very good. And now you can calculate how many good cells you have, because you have 21.4 and 7 of those are bad. So you have 14 million per milliliter, which are good fertile cells. Do you know Professor Dixon Warner from Texas A&M? No? He's world famous.
끝내놨습니다.
아, 이거. 이건가요?
위로 올렸다가 내리시.
아, 이걸요?
전체 잡고.
아,
천천히 내리시. 잘 섞여야 돼요.
That was wrong. I think you didn't get anything in.
yes.
You put it in and then you push down, because it will soak up when you push down. Yeah, it's not in.
아까.
문 열어놔서 문제가 안 되나요? 안 되나요? 안 닫히는. 안 닫혀요? 네, 안 닫혀요. 열고 쓰는 거네. 이 빛이 들어가면
깜깜하게 일단 메모리
need to push that. It will automatically select the F2 when you answer 2 when you have pressed 1.
I don't need to press the
No.
escape. Yeah.
No. It will select that automatically.
아이디 잘 섞는다.
It's okay. So you cut back.
주사위 들어가면서 여기 띄우고
Sometimes it happens that the cassette is not completely in, like the first time. Then when you press run, the actuator will try to push down the cassette. Don't touch it. Don't panic.
Yeah.
Sometimes people panic and then you risk that the instrument or they unplug it, and if the instrument is writing to the prompt, exactly when you unplug it, the prompt will crash. And then we need to have it back to Denmark for repair. So if it happens that the actuator hits the edge, just leave it, and it will automatically, after a while, it will retract and say, I have a problem. And then you put in the cassette correctly, and then you can continue. There is something called sample ID. Then you can say your agreement. Your numbers is a little bit lower than mine. It's due to the pipetting,
Yeah.
but the ratio is similar. So you have the same viability. I noticed you are releasing pipette very quickly. You should do it slowly, because otherwise you may not get the full amount of, and then you will get lower figures. To determine the thickness. And then we put a code on the cassette for the actual thickness. This code, the black dots, determines or tells the instrument what is the actual thickness of that chamber. And the instrument has a sensor down here that reads that code. So the instrument will know exactly what is the thickness of the chamber. So the calibration is in the cassettes, and we do that for you, so you don't think about it ever.
You mean
Yeah, the cassettes are calibrated.
cut?
You see, these two cassettes, they have exactly the same thickness of the window. They have the same code. This one is different.
Yeah.
So with the black code, the black dot, we tell the instrument that this has a different thickness. The thickness should be 100 micron. And maybe one dot means 100 micron. This one could be 98 micron, these two. So we tell the instrument that they are only 98 micron. Then the instrument will compensate. It will use 98 micron when calculating the volume instead of 100 micron. There is one function code we haven't mentioned yet. The zero count check, F50. That's a zero count check. Do you want to continue? Yes. Remove any cassette. There is no cassette. Close the lid. Okay. Now the instrument is measuring with nothing in the light path. So of course it should read 0. There are no sperm cells.
Yeah.
So it should be 0. And it was 0. Zero count is okay. So that's it.
Yeah.
Instrument is okay. And you can do that once a month or something like that.
Every time before we start this sample, we need to zero count check.
No. As I said, you can do it once a month. It is very clean in here, so it won't get dirty. Sometimes if you have the instrument in the breeding barn, you have a lot of dusts, and the dust may settle in the optics and create a false signal.
If we got the
If that happens, if the zero count fails,
it's the process to get rid of error.
it's to get rid of
Error count.
if you have let's say you have contaminated the lids, then it could give you a false reading. And then if the zero count fails, then you need to clean the optics. There was some cleaning. On this paper it is described how to do it.
Yes.
But these cleaning, the cotton things, they fit down here. I will show it to you. See, it fits here.
사이즈 같은 거 같아.
And then on the left side you have the lens. So this is how you clean it. It is described in this paper. And this is a very clean room, it's very nice here. So I
Is
don't
it reusable? No, just one.
Yes, it is reusable, depending on how much
원하시면 발표하시면 갖다 주신다. 근데 면봉이나 이런 거 주시면 될 것 같아요.
You should be careful because you are actually scratching the optics, the lens. No, the optical filter directly. So if you have sand on this, you will destroy the optical filter.
Yes. I see.
The first step, if you have contaminated lens, is to just use it dry, as I did here. No, the first step is to use compressed air. You know, a bottle.
Yeah.
If that doesn't help, then you can use this to physically remove the dust. And if that doesn't help, then you can humidify it with with distilled water. It shouldn't be wet, but just humid. Then try again. And if that doesn't help, then we need to take the instrument apart and clean the oxygen filter. But I don't think it will ever happen. Only if you spill something in there. If you're drinking Coke and you drop it. The cassettes are sensitive to sunlight and to humidity. So after opening the bag, you should protect the cassettes from moisture and light. Store at room temperature. There is inside the bag, there's a small bag with silica gel to absorb the humidity. And the bag is made of alum to protect it from sunlight. So once you have broken a bag and now you don't need more cassettes today, then you close it like this, and then maybe a paper clip, and then you put it somewhere. That's okay. Yeah. And these, they are okay as they are. So you can just...
이게 100개가
예.
100?
yes.
한 팩에 10개씩 해서 10팩에
I think basically what we're doing is we're making a report as a text file, and that text file can be imported in Excel. So you go in here as a folder, okay, it is today I want, here, select that, and then you select Notepad as a text editor, and then you can print the results from that folder. Now it's trying to print, but you already have a small text file, so you can go in here. Why do you have yeah. There you have the text file. Today's report. Okay. So I should open it with Notepad. Okay. Can we cancel the printing? No. Okay. My computer. Data files. Here it is. That's your text file. It has the results from today, and with Excel you can import that text file into Excel if you want to do statistics or whatever. If you ever need that, you can contact me. I can send you a description of how to do it. Finally, oh, I got this. Finally, if you have a bunch of stallions, which you have here, you would like to know these measurements. And you want to know these measurements, from which stallion was that? You can give each sample a 4-digit number. That's called the sample ID. So it means that the stallion called Balthasar, or or whatever you call them. You can give him a number, like number 1, and CASA is number 2, and Sunshine is number 3.
4 digits.
4 digits, so you can have up to 1,000 stallions. I'm not sure you have that many here. The way you do it is, before you do the measurement, you type in the number, stallion number 105, okay? Now ID is 105, and then you can do the measurement. I'll show you.
Why did it close the lid while operating?
In theory, yes. In practice, no. The lid is to protect from light that may interfere with the measurement. But I don't think it's very likely you have exactly that wavelength. So it's not so important. Now you see 105 has been transferred. So you know that this measurement was from stallion number 105,
Yes.
which is Morningstar.
Name.
The name is Morningstar, yeah. Or you can put the start code, or part of the start code. It's up to you, but you have that possibility. And the way to put it in is just type it in before you do the measurement.